Hi, this is Mackenzie Banks. I'm just going over the chapter 15 video homework, and here's what we've got. So ultimately we're trying to find the amount, what percent of chloride is removed. So we have a solution that is 0.001 molar chloride and 0.01 molarity oxalate. The solubility product constant for the silver chloride is 1.87 times 10 to the negative. The solubility product constant for the silver oxalate is 5.4 times 10 to the negative 12. We will have to add silver nitrate dropwise to increase the silver concentration until one starts to precipitate, and then continue adding it until you get just up to the concentration where the other starts to precipitate. So first we have to calculate the concentration of silver ions where silver chloride starts to precipitate. So we were able to do that. We were given the KSP, so in order to find the amount of silver ions, we just took the KSP over 10 to the negative third molarity. And that gave us 1.87 times 10 to the negative 7 molarity required to start the precipitate of silver chloride. So then our second question was to calculate the concentration of silver ions where silver oxalate precipitates. So first we did that by balancing the equation, and we already know we don't know what silver is, but we know what the KSP value is, and so we do 5.4 times 10 to the negative 12 over 10 to the negative 2, which will give us the silver, and we just have to square root that because silver was squared in order to balance the equation. So then we take the square root of that and we find 2.3 times 10 to the negative 5th molarity. And then the third question was, once you raise the concentration of silver up to the concentration where silver oxalate starts precipitating, what is the remaining concentration of chloride? So we find that the remaining concentration of chloride, we take the KSP divided by the amount of silver that we have, and we find that the amount of remaining chloride concentration is 8.06 times 10 to the negative 6 molarity. And then finally, we're going to find a percent of chloride that has been removed. We're going to do that by doing 10 to the negative third molarity minus the concentration of chloride, all divided by 10 to the negative 3 molarity. And we're going to multiply that by 100 to find that 99.2% of chloride was removed.